So, very good morning to you all people once again. Student, we are at the verge of completion of the topic and syllabus also. I would be discussing soil stabilization and geosynthetic today. If time permits, I will be sharing. If time permits, I will be sharing machine foundation, brief about machine foundation, and something about sampler. Otherwise, I will be sending PDF notes on those things. Uh, the only thing now is left from my side is numerical problem from deep foundation. I would be sending numerical problem to you all people. Try to solve those numerical problem in the Diwali vacation and all those things. So once again, I am recapping the course. In slope stability chapter, we have gone through infinite slopes, finite slopes, and certain methods for calculating factor of safety for finite slope, that is Bishop method and Palacios method and Swedish circle method. After that, in completion of those things, Taylor stability chart and some other slope stabilization techniques. In unit 2, we have gone through vertical stresses and bearing capacity. For bearing capacity, we have tabulated bearing capacity with the help of some analytical methods like Terzaghi, Mero, Prince-Hansen, Vazix, and IS code method. And after that, we have also checked out the effects of water table, effect of eccentricity, bearing capacity in layered soil, bearing capacity in slopes, rocks, and all those things. Further, we have gone through some field tests for determination of bearing capacity like plate load test, standard penetration test, standard penetration test, plate load test, and dynamic cone penetration test. Later on, we have switched to Westergaard theory and Bose-Ignace theory to tabulate the vertical stresses, in which we have calculated it for circular loading, point load, line load, strip loadings, rectangular loading, and we have also gone through contact pressure diagram and Newmark's chart and 2:1 method and certain different method, and numerical has been shared with you all people to solve it. Later on in unit 3rd, we have discussed about the settlement. In settlement, we have gone through immediate settlement, consolidation settlement, primary and secondary consolidation, and we have gone through certain numerical problem related to settlement of foundation, and I have shared the PPT of the tolerable limits, factors affecting the depth of the foundation, factor affecting the type of the foundation, how we decide these things. In unit 4th, we have gone through the deep foundation, and exclusively through the deep foundation, we have gone through pile foundation, in which we have discussed about each and every aspect of the pile, under reamed pile, and all the things which are related with pile foundation. And briefly, we have discussed about the well and caisson foundation, pier foundation, sheet piles, and all those things. Later on, we have discussed upon the only thing left in the unit 4th is the numerical problem and machine foundations. In unit 5th, we have discussed about the soil samplers, types of samples, their area ratio, recovery ratio, all those things, soil bore log chart, and all those things. What we have to do. Certainly, I will be sending PDF about all these things also. Later on, we have discussed about the dewatering, certain dewatering method like electro-osmosis methods, and the only topic left in unit 5th is soil stabilization and geosynthetic. Today, I am going to discuss about that thing also. So, soil stabilization is a process of treating a soil in such a manner as to maintain, alter, or improve the performance of the soil as a good road construction material. The changes in the soil properties are brought about either by incorporation of the additive or by mechanical blending or different soil types. Or simply, soil stabilization refers to the process of changing soil properties to improve strength and durability. There are many techniques for soil stabilization, including compaction, dewatering, and by adding materials to the soil. Purpose of soil stabilization: to improve the strength of the subbases, base, and sometimes surface courses in case of the low cost road, to bring about the economy in the cost of road, to make use of the inferior quality of the locally available soils as material. Every time it is not possible to find required or specified strength in locally available material, at that time we can go for soil stabilization methods. To improve certain undesirable properties of soil such as excessive swelling or shrinkage, high plasticity, difficulty in compacting, etc. To facilitate the compaction and increase the load bearing capacity, to reduce compressibility and thereby settlements. To improve permeability characteristics. Components of stabilization: soil stabilizing agents: cement, lime, fly ash, blast furnace, slag. Stages involved in soil stabilization process: evaluating the properties of the given soil, deciding the lagging property of the soil, and choose effective and economical method of the soil stabilization, designing the stabilized soil mix for intended stability and durability values. Different step technique of stabilization. Types of soil stabilization technique is mechanical stabilization: soil aggregate mixture, soil clay mixture, cement, sand, gravel mixture. Stabilization of soil with a soft grade. Chemical stabilization or stabilization by the additives such as lime, sodium silicate, calcium chloride, bituminous material, and resinous material. Mechanical stabilization: in this techniques, the stability of the soil is increased by blending the available soil with imported soil or aggregates so as to obtain a desired particular size distribution, and by compacting the mixture to the desired density. Compacting a soil at an appropriate moisture content is itself a form of mechanical stabilization. Principle of mechanical stabilization: mechanical stabilization is achieved by intelligently blending locally occurring materials so as to obtain the desired grading. Compaction of a soil is also a form of mechanical stabilization. It is well known as a dense, well graded mass offers high resistance to lateral displacement under a load. If well-graded material is compacted, densification of the mass takes place. The mechanical strength of a mass is due to internal friction and the cohesion. Internal friction is supplied by the coarser particles, gravel, sand, silt, where a cohesion is due to the clay friction. Application of the principle of mechanical stabilization is soil aggregate mixture, sand clay mixture, sand gravel mixture. Stabilization of the soil with the soft aggregates. Chemical stabilization: under this category, soil stabilization depends mainly on chemical reaction between stabilized cementitious material and soil minerals pozzolanic material to achieve the desired effect. Different techniques of the soil stabilization: soil lime mixture, soil cement mixture, chloride stabilization, and stabilization with the other chemicals. Under this category, the addition of a bitumen binder to a soil improves its property considerably. If soil lacks cohesion, the bitumen coats the soil particle, binds them together, and supplies cohesion. Bitumen being a waterproof material, the mixture becomes less prone to the adverse effect caused by the ingress of the water. If the bitumen binder is sprayed on dry surface of the low cost road, it prevents dust and stop entry of the moisture into the road. The following are the various bituminous stabilization techniques: sand bitumen, soil aggregate bitumen, spraying bitumen on the earth / gravel road. Advantage of soil stabilization: it improves the strength of the soil, thus increasing the soil bearing capacity. It is more economical, both in terms of cost and energy, to increase the bearing capacity of the soil rather than going for deep foundation or raft foundation. It is also used to provide more stability to the soil in the slopes or other such places. Sometimes soil stabilization is also used to prevent soil erosion or formation of the dust, which is very useful especially in dry and arid weather. Stabilization is also done for soil waterproofing. This prevents water from entering into the soil and hence helps the soil from losing its strength. It's help in reducing the soil volume change due to the change in temperature or moisture content. Stabilization improves the workability and durability of the soil. So these are some references you can go through for stabilization. Now I am going to, it is also discussing soil aggregate mixture. Soil aggregate is a material in which soil and other aggregate particles are mixed in suitable proportion such that the resulting mixture conforms to a dense and stable mix when properly compacted. This technique is used in countries abroad for the construction of the base course and in a case of low traffic roads for surface course as well. The particle size distribution of a mixture is a major factor in determining the stability. The aggregate should so be created that a grain to grain contact exists and the producing internal friction. So a specification is given for, you can see over the specification in this chart. Sand clay mixture. Sand clay road is composed of favorable mixture of a clay, silt, and sand. This blending can alter the undesirable property of the clay significantly, which can use this mixture to construct about 200 thickness road and as a surfacing course for low traffic roads. When used as a sub base mix, should have a minimum soaked CBR of 20. When used as a base of very heavily traffic road, mix should have a minimum soaked CBR of 80. This mixture gives good result only if the proper equipments are used and quality control is done. So this is a chart given for specification of sand clay mixture. Sand gravel mixture. In tropical countries, the material obtained from the disintegration of the laterite are extensively found in a natural admixture of a clay and coarse fraction and is also known as lateritic gravel. In India, this material is locally known as murum. Often the natural murum contains too much of the plastic material which lowers its value as a road pavement material. A suitable admixture of the murum with sand will not only result in a better gradation and increased strength but also will reduce the plasticity. Sand murum mixture finds ready application in a subbase and bases in India. Stabilization of the soil with the soft aggregates. A method of stabilization of a soil using soft aggregate is known as Mehra's method. The principle behind this method is to embed it in a soil mortar coarse aggregate roughly one third of the total volume. The aggregates are normally soft aggregates such as overburden brick, ballast, concrete, murum, or laterite. Because of the larger proportion of the soil mortar, the resulting material has no grain to grain contact in the coarse aggregate which merely floats in the soil. Each aggregate is thus involved all around the compacted soil and is thus protected from the crushing effect of the traffic. This enables the soft aggregate to retain its strength and angular character of the indefinite period. About 10% of the coarse aggregate which are collected are not mixed with the soil but are saved and spread on the layer of the soil aggregate mixture below before rolling. The soil aggregate mixture is compacted to maximum dry density at a optimum moisture content. There's soil lime stabilization and soil cement stabilization, chloride stabilization. So these are some different types of stabilization. You should go through this PPTs I would be sharing with. Actually, you should know to something briefly. You should know about stabilization and geosynthetic. Actually, they are very wide application of these things, but we are not having that much. So we are not having that much thing in your syllabus, so try to revise these topics uh, briefly only, not go so much into deep of these things. So I would be now talking about something about geosynthetics. I have in briefly I have discussed about the soil stabilization. I am only interested that you all people should know what is the application of soil stabilization, what are different types methods of soil stabilization, what is the certain brief thing you should know, introductory part of soil stabilization you should know, not the in-depth knowledge of soil stabilization. And similar is the case with geosynthetic. So introduction to the ASTM 2006 T4439 defines a geosynthetic as a planar product manufactured from a polymeric material which used with soil, rock, earth or other geotechnical related material as an integral part of a civil engineering project, structure or a system. A number of geosynthetics are available, including geotextiles, geogrids, geomembranes, geonets, geomasses, geowebs, and geocomposites. So these are some example in a figure. You can see this is a geocomposite, this is erosion control, geosynthetics, and these are geogrids, geocells, and all those things are present over here in a diagram. This is geogrid, try different types of geogrids used for ground improvement. This is new 4 axial geogrids, new coaxial, uniaxial, biaxial, and triaxial. So this is geotextiles, geonet, geocell, and geogrid, you can see in a figure. Now I will discuss about the geosynthetic application of geosynthetic. It is used for ground stabilization and improvement. You can see in a figure very clearly how they are applied in pavements. It is used in pavements, road, parking bays, and hard standings, runways, aprons, and taxiways of airways, in heavy duty pavements, ports and harbors, and assault reinforcement. So you can see in the diagram very clearly at which places they are used. These are the certain application. In railways, they are used under the ballast for erosion control. For in slope stability, chapter 1 of the techniques for slope stabilization is geosynthetic control measure for erosion control. In retaining walls, re-walls, and bridge abutments, nowadays we are using geosynthetics. For building foundation improvements, we are using the geosynthetics. Value engineered benefits application for capping, weak deposit capping, or improvement of layer, sub base, and sub ballast, base ballast. So these are some in the spectrum of mechanical stabilization and weak ground. So value engineering benefit is appropriate application of geosynthetic can realize the following benefits: construction cost, time savings through the reduction of the required pavement material quantities, wish list, maintaining enhanced structural performance, elongated pavement structural life span, particularly as a result of incorporating the filtration, suppression, geotextile, reduction in the maintenance requirement as a result of enhanced structural environmental conservation, mainly due to reduction in the material quantities and erosion control. Construction time saving benefits. So you can see these charts and try to understand. I will be sharing this PPT. Road over swamp crossing. The proposed road was crossing 1 point. This is a case study I would discuss with you. Proposed road was crossing a 1.2 km swampy stretch. The soil were peat with low bearing capacity with CBR of 0.5%. The design assumed the peat thickness to be 1 meter before getting onto the hard ground. The actual thickness was deeper than 1 meter. Instead, it went beyond 3 meters. The contractor wanted to finish the section before the rains started. So this is the cost as per conventional design, and this is the cost per as per the geosynthetic design. So you can see the difference. It is $384,000, and this is one. So there is a reduction in amount saved with the geosynthetic is 37.85%. So this is the way they have done. You can calculate the traffic benefit ratio. Actually, these things are not the part of your syllabus, you should just know it. So these are some structural benefit. There are some environmental benefits also of geosynthetic. You can go through these things. So students, I am not getting into the deep of this topic because it is very wide topic. Both topic is very wide, whether it's be a geosynthetic or uh, whether it's be a soil stabilization. The only thing you should know, the methods of soil stabilization and the application of soil stabilization. The basic of soil stabilization must be known to you all people. And in geosynthetic, different methods of soil stabilization, application of soil stabilization, and different material used for soil stabilization. Similar with the case with the geosynthetic, you should know the application of geosynthetic, different application of geosynthetic material used in geosynthetic, and different types of geosynthetic. So today I have a time, so I would like to discuss something about machine foundation also, brief discussion about machine foundation. Very briefly I would be discussing this topic also, because there is not to discuss much about, because it is a part of higher course, so I would try to discuss it briefly. Let me see whether we will get a topic about these things or not. I would be sharing a PDF of I will be sharing a PDF of these things, so you might be get basic knowledge of machine foundation. It is not necessary to learn in depth. You should, if you are not having in depth knowledge of uh, machine foundation, then also it is fine. So I would be discussing about this thing is left with you all people, so I should discuss this thing. The only thing which I have not discussed in elaborately was types of sample and all those things. So disturbed sample and undisturbed sample. There are two type of sample and remolded sample. Natural occurrence structure of the soil gets modified or destroyed during the sampling operation. These are also called as representative sample. Non-representative sample are those in which the soils from other layers get mixed up. Undisturbed sample, natural structure of the soil and material property remain preserved. Sample disturbance depend upon the design, sampler, and method of sampling. Design features governing the degree of the disturbance: cutting edge, inside wall friction, and non-return wall. So this is inside clearance. You can see D1, D2. This thing is very clearly given in any book. So inside clearance is D3 minus D1 upon D1 into 100%, should lie between 1 to 3%. Outside clearance is D2 minus D4 upon D4 into 100. Outside clearance should not be should not be much greater than the inside clearance. Area ratio is equal to D2 ka whole square minus D1 ka whole square upon D1 ka whole square into 100. Should be as low as possible for soft sensitive soil. It will be greater than 25, preferably less than is equal to 10%. Depending upon the area ratio, thick wall sampler, thin wall sampler. Thick wall sampler used for obtaining disturbed but representative soil sample. Area ratio is greater than 10%. Thin wall sampler used for obtaining undisturbed sample. Area ratio is less than equal to 10%. Depending upon the mode of operation, open drive sampler, piston sampler, and rotary types of sampler. So I would not like to discuss about the open drive. So you can see in a figure, these are the open drive samplers. Inside diameter 38, 70, 100, and all those things, the specification are given. This is split spoon sampler used in a standard penetration test. So you can see in the figure, it is a split spoon sampler. It is basically used in a standard penetration test. Piston sampler. Piston sampler is of two type: sampler cylinder piston system. The piston fits tightly in a sampler cylinder. Good quality undisturbed sample are obtained from piston sampler with the use of these sampler. So this is a figure of piston sampler. Rotatory sample. This is a kind of rotatory sample. Conclusion: soil sampling is the process of obtaining all these things. Sample from a desired depth at a desired location in a natural soil deposit. You can go for book likes Gopal Ranjan and A.S.R. Rao and C. Venkatramaiah, Brajam Das, and all those things. So students, now the only thing which is left with is machine foundation and numerical problems to the deep foundation. Books recommended is C. Venkatramaiah, Gopal Ranjan Rao, B.C. Punamiya, Brajam Das, and B.N.S. Murthy. You can also go through this book. I have covered all the topic. I will be sharing PDF of machine foundation with you all people. Numerical problem of deep foundation. Try to solve all the problems and all this. If you all people are having any problem, feel free to ask to me. And meanwhile, I am sharing the GATE previous year question paper. Try to solve those numerical problems. Once those numerical problems will be completed, I will be sharing engineering services papers. And the most important thing which is related to soil mechanics and foundation engineering is that the field application of these topics. Question related to GATE and engineering services examination is must to be solved. Thank you once again for your patience listening.